So just a quick recap. Parent functions are just basic common functions that you'll see all the time, and you'll want to have these memorized. Examples of some common parent functions are f of x equals x, which is just a line with a slope of 1. The square root of x, the absolute value of x. And now moving on to the next one. This is what 1 over x looks like, and it wrote a little weird on this printout. It's this answer right here. F of x equals 1 over x. This is probably the strangest looking of all of our parent functions. Notice that it goes through the points 1, 1, and -1, -1. It would be pretty easy to plug these values in and see why that's the case. But most of our other parent functions go through the origin, so it's easy to kind of identify a starting point with them, right? Most of these go through the point 0, 0. This is probably the only one that doesn't. So just make sure you note that they go through these 1, 1 and -1, -1. That's usually a really good starting point when you're working with the 1 over x parent function. All right, next we have the cube root. So if a parabola looks like this, the cube root is basically where you just take this side and flip it upside down. That always helps me think about what the shape of a cubed root looks like. These go through the origin as well. The parent function for x cubed goes through the origin. And finally, we have probably the one you might even be most familiar with, our parabola, our x squared. It's supposed to go through the origin, so this goes through the origin as well. So notice all of them went through the origin except for 1 over x. Okay, so memorize these. These are your parent functions, and they're always going to be our starting point. Starting point for what? Well, starting point for transformations. These definitions are really important. You are going to want to have a list of this written out somewhere. Or you can just snap a picture of this from your screen right now. Pull your cell phone out or take a screenshot. A transformation is the process of moving a graph around. So you're going to start with a parent function. But whenever we're dealing with a parabola, for instance, we're not usually given x squared. That's too easy. We'll be given something a little more complicated, like x squared plus 2, or x minus 3 squared plus 2. So there will be other aspects, other features inside of our functions that are going to move it around. And using transformations, you can really quickly figure out where your graph is going to be and what it's going to look like using this kind of cheat sheet right here. So let me talk about what the effects are of certain features of a function. If there is a negative sign in front of your parent function, it's going to flip your function upside down. For instance, we know what x squared looks like, right? Parabola that goes through the origin. Well, negative x squared is an upside down parabola that goes through the origin. It flips your function upside down, or in other words, it reflects it over the x-axis. That's what a negative out front does. A negative inside the function, so it would look like this. Inside, note the parentheses. Or if I started with a, let's see, write it a different way. If I started with an x cubed, that would look like this. But if I throw a negative inside, it's going to flip it across the y-axis. It's going to flip it side to side. So that would become like this, backward. Going to reflect across the x-axis. Flip it left to right. If we have a constant out in front of our function, so instead of an x squared, if you had a 3x squared, we put a constant out in front. It's going to take our normal looking parabola and it's going to stretch it up and make it really skinny. So it stretches the function vertically. It makes it really skinny. If instead of a constant, a whole number constant, or a constant that's greater than 0, if you have a fractional constant, a constant that's less than 1, something like instead of our regular x squared, if we had 1/2 x squared, that's going to condense or shorten or make our function fatter, so to speak. So it sort of spreads it out. It stretches it out. Instead of making it tall and skinny, it makes it short and fat. So I'm going to scroll down just a little bit to make room for the rest of these. The next 4 are hopefully the easiest ones. If you add or subtract a number after your parent function, so we'll do +3, it shifts your function up 3 units. If you subtract instead, it shifts your parent function down 1 unit. So plus goes up, minus goes down. Should be pretty easy to remember. The next 2, however, are what happen when you shift your parent function from inside the function. So both of the examples I just wrote down here at the bottom are dealing with the parent function x squared. Obviously, this is a square here. So these are x squared parent functions. But we're adding something inside the function. Notice that the +3 is within the parentheses that's being affected by the square. When this happens, it shifts your parabola left or right, not up or down, left or right. And it does the opposite of what you would expect. So a plus is going to shift it left. So this would start somewhere over here. And a minus is going to shift it to the right. So this would be over here. Okay, so you're actually going to need to know all of these different types of shifts. So make sure you have a list of this or a picture of it, and let's apply what we just did to some examples. In examples, we're going to have multiple shifts. Okay, you usually don't get lucky enough to just have one shift. So let me zoom out so we can get the whole question here, but then I'll zoom in so we can see it a little better. This says if f is any function, we don't know what type, we don't know what our parent function is. F of x is just some function. Then how do we get a graph that looks like -2 times f of x minus 2 minus 4 using transformations? So what we're going to do is we're going to go through here piece by piece and talk about what each individual part of this will do to the graph of f. Starting with the negative out front is going to flip it upside down. Or another way to say that is y reflection. So that's wrong, x reflection. So a negative out front of your function is going to reflect it over the x-axis. The 2 is a constant that's in front of your function that's being multiplied to your function. Since it's bigger than 1, it's going to stretch our function by a factor of 2. So this is a vertical stretch times 2. The next piece is inside the function. The -2 is inside the function. So this is a left-right shift. And since it's inside the function and we're shifting left or right, it is the opposite of what you would expect. So a -2 is going to move right 2 units. And the last piece that's added out here, this -4, is outside of the function. So this is going to shift up or down, and it's not the opposite. This is exactly what you would expect. A negative shifts down. So this is going to be a shift down 4 units. So they put a bunch of options here about what these transformations are going to do to our graph. I just selected the ones that said the resulting graph is stretched by 2, reflected across the x-axis, shifts horizontally 2 units right, and shifts vertically 4 units down. So I just found the 4 that meet this description, noted those on here, and that's how you would answer this question. The next one, hopefully we'll be dealing with, okay, we're dealing with another transformation on question 16 from Homework 8A Common Version. Whenever you're dealing with trying to figure out a transformation, we always start by looking first for our parent function. What is the parent function in this problem? Well, exponents are usually a pretty big hint. This is going to be an x squared parent function. There's a lot of other stuff going on here, but this is an x squared. So our starting point, the thing that we're going to transform, is just going to be our generic x squared parabola. So now let's talk about what transformations are taking place. The negative on the very outside is going to flip this over the x-axis, or we would call that, oh, excuse me, one second. Okay, sorry for the interruption, everybody. So this negative out front is going to flip us over the x-axis, or it's going to flip it upside down. So that would look like this. So our new function would be upside down version of the old one. The next thing is a number 2. So this 2 out front that's being multiplied to our parent function, that's going to stretch it, make it skinnier and taller. So that would make this go like that, make it even skinnier. So that's a vertical stretch. Then the next piece, I'm actually going to write this as x minus 2 in those parentheses, because that's how I'm used to seeing it, rather than negative 2 plus x. This negative 2 is going to shift us right. Remember, it's the opposite of what you would expect, 2 units. So then instead of being at the origin here, it's going to go right 2 units, and it goes down like this. It's supposed to be equally stretched as the other one. I drew it slightly different. And then finally, the plus 3 at the end is going to shift up 3 units. So 1, 2, 3, it would start right here, and it would be very skinny and facing down. So the steps of all our transformations eventually end you up with a graph that looks something like this one. That looks something like this. On this particular question, they wanted you to identify the parent function and then just click or select all of the different shifts that occur. So I just listed them over here. You would just find them on this list, and that would be the answer to that question. In 6, on the common version, we finally start getting into pictures, images of what these transformations look like. So I think the notation they use on the homework is that the blues are the parent functions and the purples are after the transformations. I don't know if they do a very good job of describing that to you, but they're telling us here that our parent function is x squared. They want us to figure out what we did to transform x squared. So if we start with f of x equals x squared as our parent function, how are we going to get this to look like this by using transformations? So let's go through it one step at a time. This is obviously reflected upside down. It's reflected over the x-axis. So that tells us we need to throw a negative sign out front in front of our parent function. That's what the reflection says. The next thing I notice is that we have a vertical or a horizontal shift So if we were here to start with, we've shifted 2 units to the right. We've shifted 2 units to the right. So what that tells me is I need to put something inside parentheses within the parent function. So instead of simply just an x squared, I need an x plus something or an x minus something squared. So the plus or minus needs to be inside the parent function. And since we're moving right, it's the opposite of what you think it would be. We would normally think of right as positive, but since it's the opposite, we'll do minus 2 units. Because we're shifting 2 units to the right. And then the last thing I notice about this function is that it's lifted up a couple of units, or no, rather it's lifted up just 1 unit. It has been raised or vertically shifted by positive 1. So we just throw that at the end. So just to recap what I just wrote down, this is the vertical flip. This is shifting right, and this is shifting up. And that's how we got from the first to the second picture. And so you're just going to take this information, copy it down in here, do your best to write it with the correct notation. And that's how you go from a picture, a transformed picture, into a function. All right. For question 9, we're doing something very, very, very similar, except our parent function is different. Our parent function for this one is the absolute value of x. So notice our starting point here is an absolute value that goes through the origin. Notice that both sides have a slope of 1 or negative 1. And we're going to be transforming it to get the purple graph. So how do we do that? So let's start with f of x equals the absolute value of x. I'm going to leave some space here in case we need it. So this is our parent function, the absolute value of x. I usually like to start kind of out front of the function. So the first thing we would normally talk about is there a negative sign out front? Yes, our initial function, our parent function, was flipped upside down, was flipped vertically. So that means we are definitely going to have a negative out front here. The next thing we look for is a stretch. Did our function get skinnier or fatter? It looks to me like it got skinnier. And in fact, I can kind of see that, like, while this has a 1-to-1 ratio for its slope, the new function has a, let's say 1, 2, 3, 4, 5, 6. A 2 to 6, I guess this is, or a 1 to 3. It's got like a 1 to 3. So the new line has a slope of 3 or negative 3, whereas the old line only had a slope of 1. That means that we were stretched 3 times our parent function. We were stretched by a factor of 3. Then inside our parent function, if we were shifted left or right, we need to account for that. We were definitely shifted. We were shifted right 2 units. So that's going to be minus 2. And then outside of the parent function, if we were shifted up or down, we need to account for that as well. And we were shifted up 6 units, so that's a plus 6. All right, so we accounted for our flip, our stretch, our shift right, and our shift up. And you just type that function right here in your solution key. Number 12.
Wait, I have a question.
Yes.
How do I put that in my computer? Like, how do I use the app? Like, what do I put for apps?
ABS and then parentheses. I think they say that in the instructions. No, they do not. I saw it somewhere on this homework. It says in the instructions somewhere use ABS as absolute value followed by parentheses. Oh, you guys can't see that at all, can you? Good question. Any other questions? Anybody online? All right. Let's move on to the next one. It's very, very similar type of problem. This one's slightly different though. We haven't done one quite like this yet because we're experiencing a flip we haven't seen before. So our parent function is the square root of x. And the first thing I'm going to look for is a flip. Now, so far, all of the flips we've seen have been flips over the x-axis. But this one is a flip over the y-axis. And if you go back to your notes, you'll see that normally with flips over the flips over the x-axis, if we had the square root of x and we wanted to flip it over the x-axis so it would make it appear down here, we'd put the negative out front. But that's not what's happening. We're flipping this over the y-axis, this direction, so the negative doesn't go out front. The negative actually attaches itself directly to the x inside the parent function. We would write that as negative x inside our f. Okay, so we accounted for our flip. Now I'm going to do that in a different color. We accounted for our flip. Now let's talk about the shifting that occurs. It looks like we shift left 2 units. So left 2 would be accounted for inside of the parent function. So that would give us a plus 2. Remember, it's positive. It's the opposite of what you would expect. And then it goes up 3 units, which we account for outside of the parent function. And this is not the opposite of what you would expect. This is exactly what you would expect, plus 3. So our new function, let me write this a little cleaner, should look like the square root of negative x plus 2 and then plus 3 on the outside. And this is how we account for the flip, the shift left, and the shift up. And let me zoom in real quick for you all so you can see how the answer would have been written. Can you see that? For square root, I guess they use the abbreviation SQRT and then a set of parentheses, and you put the interior of your square root inside there. I made a typo. This is definitely a left flip, so this should be a minus sign. Or this should be a plus sign. Sorry, not a minus sign. So ignore that. I think of all of the flips and shifts, the left-right one is the easiest to get mixed up because it's so automatic to think, well, left is negative, right is positive. So you really have to be intentional when you're putting these in. Obviously, even teachers can make mistakes on that because you're so ingrained to think that left is negative. All right, next one, very, very similar type of problem. We are looking at the parent function x cubed. So if our parent function is f of x equals x cubed, I'm going to leave some space here. Our parent function x cubed. How are we going to adjust this to account for the transformations? Well, let's start with a flip. Was there a flip? No. Was there a flip over the y-axis? No. There's no flip at all. There's only shifting. Was there a stretch? Or did our function get skinnier and taller, or did it get shorter and fatter? Actually, I think it did. The purple one actually looks a little wider than the blue one. So I'm going to try to figure out what happened here. So for an x value of 2 units, my y values should have changed 1, 2, 3, 4, 5, 6, 7, 8. According to my original parent function. But for the new function, a change in x units accounts for only a change in 2 units for the new function. So it's shorter by a factor of 4. Does everybody see how that makes sense? Instead of 8 units, Now it only has a height of 2 units at that same place. So we've gone from 8 to 2. We've condensed our function by a factor of 4. So what that means is we throw a 1/4 out front. If it made it taller by a factor of 4, we would put a 4 out front. But since it made it shorter by a factor of 4, we put a 1/4 out front. All right, now let's account for our shifting. It looks like we go left. So if this is where we ended up, this is where we started, we go left 1, 2, 3, 4, 5 units, which is a +5. And then we went down 3 units, which is a -3 on the outside. So this is the answer that we would type in. And I didn't mess this one up. Go me. All right. Question 17, again, very similar. We're just shifting this. This is the parent function f of x equals 1 over x. So I don't even think, so we didn't flip it. We didn't condense it or stretch it. I think all we did was shift it horizontally. So since this doesn't go through the origin, I usually look at these 2 points as my starting points, and then I try to figure out how far I shifted to get here. So I think we went left 1, 2, 3, 4 units, and down 1, 2, 3 units. So notice I put the +4 inside the parent function down there in the denominator with the x, but the -3 that accounts for the horizontal shift, that goes by itself on the outside. Okay, so in this example, question 10, they didn't give us the parent function. They're giving us the endpoint, the transformed function. So it's going to be our job to first identify what the parent function looks like, and then to also figure out what we did to get here. So starting with the first easy part, part A says that this is a transformation of which parent function? Which one does this look like? Is it x, x squared, x cubed, square root of x, absolute value of x, 1 over x? This is our x cubed. And x cubed starts like this, and it goes through the origin. So select this option right here. The next few parts could be a little tricky. I actually don't even know, I don't remember what they've asked. Oh, they want us to come up with the formula for this one. So we have to think about what happened to get our function to this spot right here. So when I said earlier, you're going to need to memorize what your parent functions look like. I mean that. So the parent function of x cubed goes through the origin, and I have this memorized, and you will need to have it memorized too. So it goes through the origin, it goes up like this, and then down like this, and we've first of all flipped it. The interesting thing about a flip with an x cubed is it doesn't matter if you flip it inside or outside, it's the same. I mean, think about it. If you do it on the inside, you end up with negative x cubed. If you do it on the outside, you end up with negative x cubed. So a vertical flip and a horizontal flip are the same thing. I just said that backwards, but so it doesn't matter which way you do it. So I'm going to put the negative out front. I'm going to assume it's a flip over the x-axis. So we've flipped. We don't need to condense or stretch. It looks like all we need to do is now shift it 1 unit to the right and 2 units down. So this is our function that we can build out of the parent function. So that's what we type in where they ask for what f of x is equal to. Oh, they even told you to assume that the reflection is across the x-axis. It wouldn't have mattered, but they told you specifically. They want you to identify the end behavior. Of g of x, that's a typo. They want you to identify the end behavior of f of x. There is no g of x in this problem. So our end behavior should be fairly obvious. This just goes on forever in both directions. So as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches negative infinity. That's kind of reversed. They want you to find the x-intercept, the y-intercept. These are just plug and chug. The domain, easy enough. All real numbers. Okay. Very, very similar type of problem on question 18. Unfortunately, I don't think we're going to have time to get to it today. So we're going to have to pick up with this tomorrow. Oh, it's our last problem. Guys, we got so close.